Good morning, afternoon, evening from around the globe, and happy holidays from 3D Systems. This is Corbett Jones, Vice President of Marketing for Americas and Asia Pacific, and we're happy to have you here today. We're going to cover a lot of ground focusing on 3D Systems MultiJet Printing, better known as MJP, but first let me cover a few housekeeping items. You entered the WebEx on mute, but if you have questions, please type them in the question section on the right side. We will try to answer as many of the questions as we can at the end of the webinar. So today we're going to give you an introduction and agenda around MJP, and we're first going to talk about the application focus. We're also going to talk about some use cases for MJP and the value to you, the customer. More importantly, we're going to get to our new engineering materials, and for that I'm going to bring in Jeff Blank, our Senior VP of Engineering and leader of our MJP products. So let's get to it. 3D Systems is more than just a printer company. We are a provider of end-to-end solutions in the additive manufacturing space. From software to printer, to material to service, and to inspection, we have you covered. As you can see, MJ fits into the design to simulate section of the workflow. And we have a full model lineup that includes the ProJet 2500, 3600, and 5600 to fit your needs. So why MJP? MJP is designed to help accelerate your time to market, providing you with the ability to do multiple iterations faster and with high quality to reduce your costs in rapid prototyping. If we look at what MJP can do for you, the focus is really on rapid design iterations under concept modeling. This allows you to do iterations faster, quicker, and more efficient within your processes. Secondly is functional prototypes. This is where we have design verification so you can actually touch and feel the product, assembly testing so you can see if it works in the way that you manufacture products, and then the last thing I really want to highlight is the mechanical functional testing that the new material offers. MJP offers you the ability to speed your design cycles and ultimately save you time, and we all know that time equals money. So why MJP? What makes it better? And this is where I want to talk about 3 customer values. After talking to the engineers and designers, it was very clear to us that you need high quality, speed, and ease of use. So let's talk about quality first. We know that fidelity matters, and in the example we show on the slide, you can see on the left side, the ProJet 2500 part is outperforming the part on the right side. This is actually a shower nozzle that was done by a high-end company, and they wanted to perfect water flow prior to going to any tooling. And again, as you can see, just from the insert slide, that the spray that was preferred was on the left, which was provided by the quality of the 2500. On this slide, you'll also see, not only do you see small details on the left of the MJP part, but you also see the difference in the way that the screw set is in the position. We really wanted to make sure that the quality of the part is functional, and therefore you can actually screw the screw in and out on the 3D Systems MJP 2500 part, where the competitor technology did not have the quality. Again, you could not get the result needed on a competitive product. The second thing I wanted to talk about is speed. And this is where, again, I said multiple iterations fast, but ultimately you want speed, the uptime of printing to be quick. The idea is to drive to fast, finished parts quickly. And in fact, we're up to 3 times faster than our competitor, which allow you to have same-day part evaluation. The third thing that I want to talk about is ease of use. And as I said earlier, we're a solutions company. And this is where having the integrated software 3D Sprint adds value that no one else can. And this allows you to do print checks before you print. It helps you do file repairs as you go into build cycles. And again, it'll give you build time and estimates, material estimations for your build, ultimately driving to where an engineering department could leverage the queuing model inside of it to maximize what prints happen and when. Again, focused on the total solution, making 3D printing easy for you. From a competitive advantage, this is where we win hands down. And ultimately, when you can set it and forget it and put parts into a cleaning versus mechanically clean, you win. This is where you can be doing other things to help your project or parts move faster. When you use the Easy Clean by 3D Systems, you basically put your parts into a cleaning solution in a heated bin. You walk away and you can do more work during the downtime. This is up to 4 times faster than our competitor when it comes to their mechanical cleaning of parts. Again, ease of use, efficiency. This is where manpower, labor hours really convert into dollars saved. And just wanted to show you some examples of mechanical cleaning on the bottom versus using the Easy Clean system from 3D Systems at the top. You can see that all of the entrapped product or support material is out of ours, and even in mechanical cleaning, you could not get it out of the competitor part. So in this past couple slides, we gave you an overview of what MultiJet Printing is really set up to do, where it fits in the digital workflow, the target applications, and the customer value to you. This didn't stop us from continuing to grow the market for MultiJet Printing. So we asked the designers and engineers, what's next? What do you need? How can we improve the machine? And this is where we decided to say we need to move on the material properties and give you more capabilities within the materials. So I'm going to introduce Jeff Blank, and he's going to be talking about our new engineering grade plastics that we recently introduced. Jeff?
Thanks, Corbett. I appreciate the introduction and appreciate the opportunity to have this conversation about the newest and latest and greatest for our product lines. Just to give a really quick snapshot of who I am, I've been developing products for coming on 3 decades now, and so I spend a lot of my energy trying to develop our best, reliable, high-quality products and technologies, myself and the engineering teams. Corbett already did a very good job going over the 2500 and the MJP advantages, and so as a technology, you know, it delivers speed much more than our competition. It delivers fidelity, and again, as an engineering team, that's what matters, so that your parts are true to CAD, delivers great ease of use, and it delivers a lower total cost of operation than our competition, all because of the jetting technology and the materials and the processes that we've selected and that we've designed. So what I want to get into now, though, is our materials, and we've always had a very good set of materials in the rigid plastics, stiff, high modulus, low elongation, high heat deflection temperature, you know, in white, black, clear, gray. A lot of good technology there, and a lot of good elastomers, flexible, high elongation. But where we've seen a place for newer and better materials is what you would consider engineering plastics, materials that are tough, durable, kind of that, you know, mid-modulus, high elongation, really good high impact strength material. And that is really what we've decided to focus on and what we've introduced in the last month and what's available now. And those are the materials that are really there for functional prototyping. And as Corbett described, functional prototyping is when you don't just want the look and the form, but you want it to operate like the real part. You want to put it in life testing or dynamic testing or shipping or, you know, a motor test or pumps or gears or pulleys, and you want to do all of that prior to going to expensive hard tooling so that the engineers can iterate their design and know what they have is going to operate like the final material prior to, again, going to that expensive hard tooling. And that's really what this brings for us. So this next slide is just a quick snapshot of the materials. Again, lots of rigids and elastomers that we've already had, and so today we'll focus on the addition of the engineering plastics. But you can see in some of the pictures the secondary operations, the assembly, the dyeability of it. So again, really good plastic material set. The first material I want to introduce is our VisiJet armor. So that's our tough ABS-like impact-resistant material. It's a very tough material. It's good for snap fits. You can see in the video to the right. Drilling and tapping, superior versus competition in terms of its mechanical performance, and it has a world-class clarity and finish. On this next slide, what you can see are some of the specifications behind that material. And so really a good elongation to break and a good impact strength. It's really suitable for all of that functional prototyping. You can see the stress strain curve to the right at the top. And then below, numbers are great, and I love having the numbers and talking to them and being able to compare them against the competition. But, the reality is the video of that Frisbee showing how, our material versus competition, is stronger in that kind of real-world human impact test. Pictures speak 1,000 words. So we can go to the next slide, and the next material that we'll show is ProFlex. And so this is more of a polypropylene-like high-impact material. It's what I would class as a durable, bend, don't break material. Excellent for living hinges, parts needing that full actuation and multiple full actuations. Again, exceptional clarity, and when you want that deformable plastic of polypropylene-like, this is the way to go. On the next slide, we can look at the specifications on it. And what you'll see is very high elongation to break and very high impact strength. And similarly, in the video again of the Frisbee against the wall, the competition Frisbee shatters compared to the ProFlex material and its performance in that real world impact test. And so we'll go ahead and let that play. So we'll go ahead and play that video again. And so what you can see is, our material, again, designed for that toughness and that impact, and then a competitor material, and this is real world. And I don't know about you, but I would prefer my material survive that relatively simple stress test. So the next material that I want to talk about is our VisiJet rigid materials. And so our rigid materials have recently completed their testing and are now classed as medically capable materials. And what that means is there are lots of applications, especially in the world of 3D printing, where you're going to want human contact, either short-term skin human contact or mucosal membrane if you have a surgical guide. So our materials have now passed our USP Class 6 and our ISO 10993 testing, and that's fantastic for those kinds of applications. And so on our 2500 and our 5600, that biocompatibility certification allows you, the end user, to use those materials in all of those medically required areas where that specification allows that contact. And so that is available today on those rigid materials. And then the next material to introduce is the VisiJet Gray for the 2500 plus. So this material was designed very specifically for exceptional fine feature detail. There's a set of color palettes that the industry wants, and this primer gray is exactly that. And so if you see in some of those images, and so these come from our Gentle Giant studios in Burbank, California, and these are examples of the kind of high fidelity work that they'll do in their models. You also need that high fidelity work in engineering parts. It's ready to paint immediately, no additional post-processing prep work, and that material has exceptional fine feature detail for all of that, really delicate work. And so the next thing I want to talk about is to shift gears away from materials a little bit. Now, all of those materials I hope you saw in the specifications and in the videos really elevate our game for functional prototyping. What we're also introducing is something called shells and infill. And so Corbett talked briefly about 3D Sprint, our world-class, front-end software. We've added a feature into 3D Sprint called shells and infill, which allows a user to take a solid part and hollow it. So with a push of a couple of buttons, you can hollow that part, create that sparse infill wax pattern. And what that allows you to do is make a dramatic reduction in the cost of the part in terms of the material usage and the weight of the part, and still maintain via that lattice structure that structural stability with less distortion. And the key is you apply that to the CAD file. You don't have to go change the CAD file. From an engineer, the CAD is the CAD, and they want to be able to do prototyping in the CAD without changing it. But everybody wants to be able to save money and weight in their design, and so you can apply that without having to modify the CAD file. You apply it in 3D Sprint. And so if you look at this next slide, this is a couple of good examples of the application of 3D Sprint. The element at the top is actually a component of the 2500 printer. It's our MDM, our Material Delivery Module block. And so by applying shells and infill, we had a 73% weight reduction and a 34% cost reduction. And so we could use that as we iterate the design, as we look at fit and function, as we put it through dynamics testing and running testing, et cetera. This allowed us to iterate the prototype. The bottom is an example that I actually think is more production than prototype. This is an aerial drone. And so by doing that shells and infill hollowing, you have a tremendous weight reduction and cost reduction. And the reason I say production is I highly doubt that drone's going to fly very well if that was a solid block of plastic. And so just examples of where this can really add to the capability, functionality that the engineering or design teams do as they go through their work process. And then this shells and infill is available today on the ProJet 2500, 2500 Plus wax and the 5600 printers, and so it's available for all of you users to immediately take advantage of. So to kind of wrap up on this section here, I'm really happy with the work that the team has done. I think that the engineering team and the whole 3D Systems community is delivering on the promise of really good, ease of use, speed, fidelity, and functionality, right? Functionality in terms of impact, functionality in terms of toughness, functionality in terms of a material set that really emulates the end-use material choices that the design teams are going to want to work towards in ways that allow you to functionally prototype, evaluate your design, and deliver best-in-class results. So with that, I'm going to hand it back, Corbett, to you.
Jeff, thank you, and thank your team for putting the effort into getting these materials out there for the customer. Obviously, growing the capability is extremely important in the evolution of this machine. What we want to do now is go into a couple of use cases and customer stories. It's always good to learn how real customers are using the technology. And this first one is actually a local partner called Hyde Park Partners, and they're a conglomerate of a few entities. And one is AEG. It's their engineering arm that designs products for countries around the world. And this is actually the challenge they had was they had to redesign what they called Firefly. And it's an off-grid power LED light solution that the rural communities in Africa use. And this was something that Clifton reached out to us locally and said, "Hey, I need help because we need to change this and make it better." And so we talked to them and we put a 2500 plus. We looked at materials and we also looked at 3D Sprint as a way to solve that. They brought the product inside, and a quote from Clifton is, the advantage that he had with the technology advantage of the ProJet 2500, he was really surprised about the build quality, the speed and ease of use of this machine, and he actually is not new to additive manufacturing. And when you add in the cost of the machine, he is really excited about how it could help grow his business. From a results perspective, he was able to save over $9,000 in just prototyping for this particular part. And the time it went from 10 days of prototype outsourced to 1 day doing it internal. Good example of the platform of MJP and specifically the ProJet 2500 Plus. Another example that we'd like to talk about is Bushnell. Bushnell is famous for optics. They make binoculars, scopes for guns, and other products out there. And they had a challenge that they really wanted to achieve small, finely detailed parts to give them high resolution, but with the tolerance that they could get out of traditional machining, but without all the all that machining done prior to design. Cost them a huge amount of money. And you can see in the picture in the middle the detail that was needed around the parts that were being built. So we talked to them and they said, okay, let's use the 2500 again with 3D Sprint. But in this case, they're using the VisiJet MR2 material. And so what were their results? The results, this is hot off the press, and they were very happy with the true to CAD accuracy. Obviously, being small parts and pieces that go into their optics, they needed resolution, and they got that with the 2500. The design verification was critical. They could print parts overnight, come in the next day, and they could start assembling them. But where they really got it is in the savings when they brought prototyping from external machining resource to printing internal. And this added value not just for the group that was doing the design on these parts, but it's adding value throughout the business. And a quote from Jake, who's the R&D engineering manager of optics at Bushnell, he said, if we were to machine all these parts, the cost savings by printing them would have been realized long ago. And the final case study I wanted to talk about is actually an MJP application that's being used in aerospace. And PPI, a customer in the United States, is a contract manufacturer, and their problem was they needed to protect a very expensive aerospace motor throughout the cleaning and shipping process. And so again, the 2500 was a perfect fit for them. They were looking for low modulus, semi-rigid covers that they could print on a printer. And so we said, let's use VisiJet ProFlex materials. The results here are phenomenal. They actually save close to 50 hours a week in manual labor required to assemble and put protective cases in place. That's real dollars every week that they're getting from the benefit of using additive manufacturing. The other is it gave them the ability to do quick assemblies in a watertight shell so they could actually clean the motor much more quickly. And then obviously the other thing they needed to do was protect the motor during shipping. And they did this, and with the performance of the part, they're actually able to reuse the parts in their manufacturing process. So the VisiJet ProFlex printed perfectly in terms of dimension. It also demonstrated the ability to deform. So when hit, it would flex and come back to shape. And this allowed cleaning and shipping of these motors, and they basically resolved all their issues with the one machine. So that's it from a presentation standpoint. We really appreciate you joining us today. We are going to take a few questions for this. And just so everyone, before some people leave, you will get a recorded version of this webinar and the contents included be sent via email to you in the next 24 to 48 hours. And then we'll follow up with each one of you individually as we move out through the rest of the year. A couple questions that I see have come in. The question is, do you offer services for prototyping? And the answer is yes. Part of our solution set is our on-demand manufacturing team. They have resources throughout the world to support what you need. If you have a part prototyping need or even assembly need, please go to our website, 3dsystems.com, and go to the on-demand solutions, and there's a call to action of get a quote. That will engage one of their inside application engineers that will do an outbound call to you and engage you and get a part printed based off your application. Are we going to be getting a copy of the presentation and recording? The answer is yes. Jeff, I've got a question for you. The question is, can you speak to the water resistance and low temp properties of the new materials?
Yeah, I mean, from a water resistance standpoint, I mean, again, for the new materials, the ABS-like and the polypropylene-like, we test them for, in submerged conditions. We actually have some people using them in submerged conditions. And so they're, as water resistant, I would argue, as the kind of standard injection molded materials. And low temperature, we test, again, we have environmental chambers, we test at the highs and the lows. So, everybody's application is going to be a little bit different, and these are not exactly the same materials as the, ABS and polypropylene thermoplastic, but we have tested in both our machine and in our chamber conditions, and we were very comfortable that we have a good functional plastic for those applications. And again, we have an applications engineering organization, so for people that want more details, we can certainly benchmark example parts, and we can help them meet their specific needs.
Thank you. Here's another one for you, Jeff. The question is the goal of trying to print masking aids, and can the new materials simulate mating connectors?
From a precision standpoint, absolutely. We do a lot of the sample stuff. Some of the videos, I think maybe were even snap fits and buckles. So we do print electrical mating connectors as an example and as a test for the precision that we need to show. One of the advantages of our technology above the competitor technology, because we actually have heated print heads and phase change support material, we have incredibly fine feature detail and edge definition, again, true to CAD accuracy. So from a mating standpoint, mating connectors, absolutely.
Okay. Another question for you is, can you talk about the products used in the Easy Clean finishing process? Are there chemicals? What chemicals are used in that process?
Yeah, in the Easy Clean process, so it's essentially a steamer, and so the majority of the bulk wax removal. So we use a wax in our support. So the plastic material itself is, of course, a photocurable acrylate. The support material is a wax. The majority of the bulk removal in the Easy Clean is a steam system, and so it's just water, steam, for heat removal of the bulk wax. And then for fine finishing, there's a kind of a simple solvent, easy rinse, or there's a mineral oil. So there's a couple of different options for the final cleaning step. All of the detailed specifications you can find online, including the MSDSs. It's considered an office-friendly class of cleaning technology, and so you can use it, wherever you want to use it.
Okay, and then another question. What makes your printer faster than the competition? Is it the print speed? Is it the post-processing? What is it that makes your printer faster?
As always, there's multiple answers to that question. So from a print speed standpoint, we have a very, very high-speed, high-throughput print head. And we've architected the print process. And again, we have multiple products. We have the 2500, the 3600, and the 56, all of which are a little bit different in architecture. So I'll speak specifically to the 2500 as an example, but it carries to all of them. It's faster by virtue of the amount of material we lay down, the speed upon which we jet. It's and the process by which we jet, we interlace the rasters in the jetting process, and then as we build. We also have it because it's a 3-lane system. If somebody has to get a quick job done, we can focus on one lane of printing, and that goes really fast. Versus if they want to fill the full platform, and then it's the 3-lane, and so you print in bands, if you can imagine what I mean by bands. So the printing process and the way in which we drive the print head and jet is part of it. The post-processing is also part of it. In competitor technologies where you have to take the part and you go into a hooded area and you water jet to get rid of the support material, each individual part has to be post-processed. We bulk post-process, and so you can take that full plate, you put it into Easy Clean or in an oven system, either one, and you can bulk remove the material for quicker. So it's really a combination of the whole thing. Our job is to look at this from a full system standpoint. We don't want to deliver the machine, but it falls short on the post-processing. So it is a combination of both, which really drives that improved productivity relative to competition. I myself and the team that have developed these products have been developing jetting-based systems for multiple decades, and we understand how to get the most out of it from a productivity standpoint.
Great, thank you. Question on build volumes. Can you kind of talk about the build volume of the different models within the platform? What size is the 25, 36, and 5600 build platforms?
Yeah, so 25 is, I'll just use round numbers and I'll use US. 8 inches by 11 inches by about 6 inches deep. 3600 is pretty close to the same. It's a couple of inches deeper, so let's say 8 inches deeper. And the 56 is a very large product. That's for our largest builds. And so it's 21 by 15 by, I think, 10 or 12. You're asking me to do this by memory. And that's our largest product. And so, in the 5600, again, just to mention, is a multi-material product. And so in that product, you can have both hard and soft material at the same time. You can have different colors of materials so that you can do blends at different durometers. And so we have that breadth of product coverage just so that it can meet the needs of various customers, whether it be for size or be for productivity.
And again, we're not going to get.
I'll refer everybody to the website, obviously, if people want the exact numbers. All that information is out there in the spec sheets.
Okay. We aren't going to get to all the questions, but one last one, Jeff, that you could address is explain or talk through the material change process. What does it mean to change from one material to the other? What does someone have to do with the machine?
Yeah, so in the machine itself, there's going to be the bottles for support material and the bottles for build. And one of the advantages of MJP technology, because we're in bottles, not cartridges, you do have the ability to change the material, and you don't have to drain a vat, et cetera. When you want to change the material, if you wanted to go from one material to another, some of the materials, by virtue and some of the use cases, you may not care if there's a blend of, if you want to go from a black material to a white material, the user in prototyping fashion may say, hey, I don't care if there's a little bit of gray material for this prototype in between. And so we have a print-through MCO, material changeover, whereby you can just swap the bottle, print through, and not have to, empty out the material. If, however, the user wants very specifically to empty out the material because they want, their next part to be pure in the next chosen material or color, then there's an MCO process whereby you can basically purge out and remove the material from the reservoir as you put in the new bottle. So we're trying to give the user flexibility in the way in which they make that change depending on their end goal.
Awesome. Thank you for that. And thank you, everyone, for attending today. Again, you'll be getting a follow-up email with the recording of this webinar that you're welcome to share. If there are specification things, like Jeff said, please check our website. And ultimately, you're going to be getting the opportunity for 3D Systems to reach out to 3D Systems and ask for more engagement if you'd like. If you do want us to contact you, please do that, and we will get back to you with an application specialist in your area to talk about specific application needs you have. Thank you again, and happy holidays from 3D Systems.